So we are continuing to look at the solutions for the mock final that I posted. And Andrea, so far the three problems were you able to try on your own and were you able to solve them?
Yes.
One second. There
Yes.
is some echo. Yeah. Okay, good. So that's good. So let me continue with trying to solve problem 4 and 5. And I also want to do one more problem related to problem 4. So if you see here, this is a second order differential equation. The second derivative d squared y over dt squared equal to y e power minus t. Or in other words, on the right side, there is a function that may involve either y, time, and the derivative of y. So it could involve either of those in some combination. We are asked to solve this equation with the Euler method with a step length of 0.25 with the initial condition that y of 0 equal to 1. Clearly show the steps towards the final answer at each time point and tabulate your answer in this form. That's what is asked, and that's a typical question you can expect in the exam. Now you could do everything fully by hand, or you could do some of it by hand and use Excel to set up the calculations and help you along. I give full flexibility in the exam to bring your laptop or calculator, whatever you want. So let me go over the solution steps, okay? All right. So I'm going to open my PowerPoint, have this ready. We did press record, yep. Okay. All right, so now problem 4. D squared y over dt squared equal to y e power minus t. So step 1 in these problems is to do the transformation. Transform the second order ODE to 2 first order ODEs by setting dy over dt equal to z. If you do that, you're going to get dy over dt equal to z, and d squared y over dt squared is nothing but dz over dt equal to y e power minus t. We can generally say this is a function of time, y, and z. So those are your two equations. And in fact, you need initial conditions, y of 0 equal to 1, that is given. And in the mock exam, I think I made a mistake that I haven't given what is y dashed of 0, which is z of 0. Let's take that to be 0. Missing, but now I'm adding. So I'm going to fix it and repost that, but added now. Okay. So you have y of 0 equal to 1, z of 0 equal to 1. What you're asked to calculate is only y, but you can't calculate y alone. You have to calculate z and y simultaneously. So to do that, the next step is write down the Euler's method. Euler's method for one variable. That is, if you have dy by dt, or to avoid confusion, I'll write this as you have dx over dt equal to f of x comma t. Euler's method is x of t plus delta t equal to x of t plus delta t multiplied by f of x comma t. This is Euler's method for one variable. Now you need to apply this for y and z. Both of which are functions of time. Okay, so how do you do that? So in the exam, I would strongly suggest you to write it out. Y of t, y of t plus delta t equal to y of t plus delta t multiplied by z of t. And then z of t plus delta t is z of t plus delta t multiplied by f of t, y, and z. What is f? Recall. F of t, y, z is in the problem, which is ye power minus t. Y of 0 equal to 1, z of 0 equal to 0. These are both given. With this, you want to calculate what is y of 0.25 and z at 0.25. So how do you do that? So for advancing the solution to t equals 0.25, you start with, for advancing the solution from t equal to 0 to t plus delta t equal to 0 plus 0.25 or 0.25. So you write y of 0.25 equals y of 0 plus delta t multiplied by z of 0. Z of 0.25 is z of 0 plus delta t multiplied by f of 0, y of 0, z of 0. This is nothing but what is y of 0? What is y at 0? This is like asking ye power minus t evaluated at time 0 and y equal to 1. Y of 0 equal to 1. So this is z of 0 is, so next page. I mean, I'll give you just a second to write this down. Okay, remember y of 0 is given as 1, z of 0 is given as 0, delta t is 0.25, y of 1 multiplied by e power 0 is again 1. So this is like writing y of 0.25 equal to 1 plus 0.25 times 0, which is simply 1. Z of 0.25 is 0 plus 0.25 times 1, which is simply 0.25. So if you go back to the table, you have y at t equals 0.25. You have to fill out the entry as 1. Of course, z at 0.25 is not asked. If it were asked, it may be asked, is 0.25. Okay. Is it clear, Andrea? Are you able to follow?
Yeah, I'm following.
Okay, good. So then you want to then go ahead and compute for t equals 0.50. That is, when t equals 0.25 and delta t equals 0.25, you can get t plus delta t equals 0.50. It is for advancing to 0.50. So you do the same thing. Y of 0.5 equals y of 0.25 plus delta t multiplied by z of 0.25. And then z of 0.5 is z of 0.25 plus delta t multiplied by y of 0.25 times e power minus 0.25, that is e power minus t. So what is y of 0.25? That is 1. So this value is 1. Of course, this is 0.25. Z of 0.25 is simply 0.25. And you can plug in the values. So I'm going to write y of 0.25 or 0.5 is equal to 1 plus 0.25 times 0.25, okay, which is 1 plus, what is 0.25 squared? I think this is 0.0625 or 1.0625, and z of 0.5 equal to 0.5 plus, what is y of 0.5? That is 1 e power minus 0.25. So I'm going to use my spreadsheet. So that is 0.25 plus 0.7788. So that is like 88, 12, 10, 1.0288. So you would put this in the table and fill up for the second row. So now we have done 2 time steps. Okay, I'll also show you the spreadsheet that I've set up, which you can also set up beforehand or during the exam. It's really simple to do, and I can show you how we are able to do this in the using Excel. Okay, so if you are able to follow so far, I'm going to go back and share my Excel screen. So here is the problem. Okay, so here is the spreadsheet for Euler method. Okay, so the step length is 0.25. Okay, initial condition, you can call that 1 or 0, that is just a counter. Okay, time 0, and then the values are 0.25, 0.75. So I'll say this is 0, 1, 2, 3, and 4. So this is again, I'm going to copy this. So I'm increasing in steps of 2. That's obvious. All right. So initial condition, instead of x of t, I'll call this y of t, z of t. That's fine. That's our transformation. Y of initial condition, y of 0 is 1, z of 0 is 0. Okay. And then k1, what is our k1? That is, if you write dy by dt equal to f of t, or this is just z. Okay. And then dz over dt is f of t, y, and z. That's the nomenclature I just wrote. And f of t, y, z equal to y multiplied by exponent of minus t. That's the function given in the problem. K1, L1 are evaluated at t comma y comma z. So if I go to K1, that is simply equal to z, and then L1 is the function y e power minus t evaluated at the previous time step. So that is y multiplied by exponent of minus whatever time is, close bracket. So then I have to write y of t plus delta t is y of t plus z multiplied by delta t. And then z of t plus delta t is z of t plus delta t multiplied by L1. So I'll write this as y of t plus so if you look at the first two values, just these values, we can definitely see if we are on the right track. Okay, so let me just drag these down. Okay, so if you just look at the first two rows, okay, we got y at 0.25 as 1 and z as 0.25, and then y value as 1.0625 and z value is let me see what I got here. Oh, I have to multiply this by, so I left out a factor of 0.25. So I have z of 0.25, which is just 0.25, multiply plus delta t times y of 0.25, which is 1, multiplied by e power minus 0.25, which gives me 0.4447. That is this value here. Okay. So I'll delete these annotations. Y of t is evaluated as y of t plus delta t is evaluated as y of t plus dt times k1, and then z of t plus delta t is evaluated as z of t plus dt times L1. So this Excel file corresponds to what we wrote on the PowerPoint slide. So if you see them together, it should make sense. So what you need to copy and put in the Word file or the table is these values, okay, which I'm going to do now. So far we have been seeing the Excel file. So let me now share my Word file. So you're seeing my Word file. Okay. So I made this correction. I added the initial condition for y dash of 0. And then I'm going to write y at t equals 0.5 is so this is time. This is 0.00. Just making sure that it is easy to follow. Okay. So 0.00. What is the y value at 0.00? That is just the initial condition, which is 1. And then the z value at 0.00 is simply 0. And then 0.25. What is y at 0.25? 1.0000. Always the exam report to 4 decimal points. And then z is 0.2500. To actually make it a little easier, let me show it this way. So here is my Word file that you're seeing. Okay. Within that, I'm going to bring my Excel sheet and keep them next to each other. All right. So you're seeing both. I'm just going to copy these 4 rows, or sorry, I'm going to copy these 8 cells into here so that you can see them together. Okay. Just have to organize this, otherwise I can't have both the windows. All right, there we go. So you have 1.00, 0.25, and then at time 0.50, I have 1.0625, and then 0.4447, and then 0.75. I have 1.1737, 0.6058, 1.00, 1.3251, 0.7444. So these are the numbers that you need to fill out. There is all the things that are in bold are already given to you. These are the ones that you need to fill out by doing the problem, and you can use just calculator or Excel sheet like I showed you. Either is fine in the exam. So I see that Kimberly has joined. If you have any questions, please ask. Okay. So, all right. So this is problem 4 in the mock final, where we have a second order ODE and we reduce them to 2 first order ODEs and then solve for the variable that we care about, which is y, and the intermediate variable, which is z. Here are the numbers. So please try this and let me know if you have any questions. Okay. So this is if you are asked a second order ODE, I'll always ask only the second order ODE with a simple method like Euler's, which is just one step. I also want to do like a bonus problem where we try to do this with a first order ODE, but with the RK4 method, because that is arguably the toughest method we have in this course. So I just want to do, or at least go over the solution when you have this multi-step method. Okay. So I'm assuming that you have seen this, or at least done the homework. Of course, you have done the exam, so at least I'm sure you have seen this method. Okay. So if our equation is of the form dy by dt equals to a function of t and y, which is in this case, let's say we will change it up a little bit. We'll say this is y minus y squared times time. Yeah, something like that. Minus y squared time. I'm just making it up. Okay, it's not something that we are taking from any book. I'm just taking a problem and using it to demonstrate our method. All right, so we are going to use a step length of 0.25, and we'll say that the initial condition is y at t of 0 equal to 1. Okay, this is our initial condition. Initial condition y of 0 equal to 1. Initial condition will be given in the problem, so you don't have to worry about knowing it. It will be provided. So we want to develop solution for time up to 1 in steps of 0.25. Okay. Are you with me so far? You're able to see that we are setting up the problem?
I'm following.
Okay. All right. So first you need to remember, or at least, you should look up the formula for the RK4 method, which goes as this. This is the RK4 method or formula. Okay. So you need to write y of t plus delta t is equal to y of t plus delta t multiplied by a1 k1 plus a2 k2 plus a3 k3 plus a4 k4, where a1 a2 a3 a4 a1 and a4 are 1 over 6, a2 and a3 are 2 over 6. That's why I have them punched in here, 1 over 6 and 2 over 6. And the value k1 is the function evaluated at t comma y. That's what I'm writing here, so that when you later see these notes, it will make sense. K2 is the value of the function evaluated at t plus delta t over 2 and y plus half k1 delta t. And k3 is the function evaluated at this t plus delta t over 2 and y plus half k2 delta t. And k4 is the function evaluated at t plus delta t and y plus k3 times delta t. So if you go to k1, so first of all, you need to be clear what this function is. The function, I mean, the function, this f of ty. So by function, I mean f of t comma y evaluated at t and y. That is at the current time. So if I go to k1, this is of course programmed for a different problem. So all this is going to be wrong. That's why I'm going to delete this and start over. So what do I have here? This is t plus delta t. That is the t meaning the current time. So if I see here, this is the current time plus the step length or delta t divided by 2. So 0 plus 0.25 divided by 2, which is 1.25. Okay, so you can see that this cell F4. So now if I take K1, K1 is the function which is minus 1 times y squared. That is, when I'm trying to update this this row, my previous row is the current, and my current row, I mean this row is the next step. So everything has to be based on the previous row. So this is minus 1 times y squared, y being this squared times time 0. Why? Because we have a 0 here, y squared t is simply 0. And then this y1 or this y plus half k1 t is simply taking this y value, which is at O, plus half times k1. K1 happens to be 0 times delta t, which is 0.25. So that also is 0, so that's fine. And then k2 is the function evaluated at these two values. Okay, if you see here, k2 is the function evaluated at column F, that is F4 and G4. Okay, so what is that? That is minus 1 times y squared times 0.125 or t plus delta t over 2. So that is minus 0.1250. The sequence is, to get K1, you need to know this initial condition. To get K2, you need to know K1. To get K3, you again need to know what is K2, which is minus y squared times time multiplied by time. So that is minus 0.1211. And then this is minus 1 times y squared times time. The different, what is the difference between K2, K3 and K4? K2 is evaluated at t plus delta t over 2. K3 is evaluated at t plus delta t over 2. K4 is evaluated at t plus delta t. And the corresponding y value is y plus K3 times delta t. So if you have all these, you go here. This is like saying y at the next step. This is basically formula. Cell O4 is basically this statement. This is implemented in cell O4. Okay, so this is like saying the value is this 1 plus delta t is delta t plus a1 k1 delta t multiplied by a1 k1 a2 k2 a3 k3 and a4 k4. So if you do that, you get 9697. But these are not yet updated. That's why it's showing only 9697. But if you extend this, so this final column is your solution. If you do this as a hand calculation, what you would do is first compute 4 values of k1, k2, k3, k4, get this number, again do 4 calculations, that is k1, k2, k3, k4, get this number. And if you are going to do this for 4 rows, that is 4 values per row, that is 4, and then 4 such rows, 16 calculations that you have to do in order to get this column done. So this is what you need to enter this into the final answer table. So it obviously takes practice in order to be able to do this 16 calculations correctly and get this number. So usually students make mistakes in some intermediate step. If you lose one step here, then all of these answers will be wrong following steps. So it requires some practice. But if you have this sheet and know how to change it for any given problem, what will change in a problem? This function will change, this time step will change, and this initial condition will change. The rest of the formulas are the same. Of course, you have to update the formula for k1, k2, k3, k4 because those are the functions specific to that problem. If this function were something else, you have to calculate k1 differently. That is, you have to punch in a different formula here. If you know how to use this sheet, you can use it for any problem. That's what I've been saying since the beginning. Do you want me to write it out, or I've written it out in other videos, but if you want me, I can do it. But if this makes sense, we can keep going.
We can keep going.
Okay. Do you have like another example that you want me to try with this RK4? If you have something to suggest for a function, I can try it. We can do one more example before we go to the 5th problem.
I'm personally okay with RK4. I'm not sure if Kimberly wants to.
Yeah. So that is it all comes down to what is on the right hand side. Sometimes it is just a function of only time or only y or both. You just have to do it patiently. It's really simple the way we have set it up. The trick with the second order equation is reducing it to 2 first order equations and then implementing the Euler method twice. In fact, you see here, this is 8 calculations with the second order equation. Even for the first order equation, the RK4 is 16 calculations that you need to do in order to get the answer correctly. So getting one or the other, one is just a little tricky, but fewer calculations. This is more straightforward, but more calculations. That's all. Okay. So if we have time, we'll come back and do this another example, but let me move on to problem 5, which is related to statistics. During the course of a motor test, the RPM is measured and recorded at intervals as these 6 numbers, 990 and so on. Calculate the mean value, standard deviation, best estimate of the true value for this data set at 95% confidence. Over what interval would 50% of the entire population of motor speed values fall? Okay, so let me just directly solve it here. Mean value. So if I write that is x bar equal to 1 over n I equal to 1 to n xi. Now, of course, your n value here is what? 6. And your xi values are these numbers. So you just have to write this is 1 over 6. You can use this, do this with Excel or do this directly. I don't care. All it matters is you get the numbers and formulas correctly. So this is equal to so what do I have here? So this is problem 5. $990, $950, $1,050, $1,980. So if you want the average, I mean, I'm not saying you should use Excel only. You can do this using Excel, or you can just do sum and divide it by 6, which is actually comes out to be 1,000. So this is 1,000. And then calculate the standard deviation. So you can write this minus so you want to square this and add, and then you want to, I mean, this is basically x minus x bar squared, and then divided by not 6 but n minus 1, so that should be 5, and then we want to do the square root of this. This is the standard deviation. Okay, the reason I'm putting it like this is because Excel also has formulas which you can directly use, and you can just check that our method is correct. Oops. When you use the standard deviation formula, you want to use the stdvp.s what's the problem? Some is sum divided by 5 square. I wonder what's the problem here. But the formula I had in class is, I go back here, standard deviation, that is sample standard deviation, is sigma x equal to square root of 1 over n minus 1 times summation I equal to 1 to n xi minus x bar squared. xi minus x bar squared. This is the formula I had, and using that formula, I'm getting 35.7771. And then best estimate of the true mean. So first you need to figure out what is the standard error estimate, call it SEE, that is equal to the t statistic at a given level of confidence and degrees of freedom, which is defined as n minus 1 multiplied by sigma x divided by square root of n. So thing is, you need to work out what is t, okay, from the t table which will be provided, okay, or if this is a problem about normal distribution, that will also be provided. So that t value, I'm just going to use Excel also to to extract that, or actually hold on, since this is a demonstration, let me actually read it out for you. You have your probability and statistics handout with you. You can also try reading it out from the book, that is from the handout. So here's the table for 95% probability and 5 degrees of freedom. Can you read out the t value?
You said 95?
95, yeah, that 95% confidence.
That'll be 2.571.
2.571. So main mistake you could make is, especially when the number of observations is small, if you don't do the n minus 1, you might read this instead of this. So this is the number we are looking for, 2.571. Okay. So the t value is 2.571 from the provided table for 95% confidence and nu equal to 5, equal to 6 minus 1 equal to 5. And then sigma x is known, square root of 6 is known. So you just need to plug in these numbers, 2.571 times 35.7771 divided by 6 power half, that is square root of 6. So if you do that calculation, 2.571, that is this multiplied by this divided by square root of 6, which is 37.5519. 37.5519. So how do you write that statement? The best estimate for the true value for this data set with 95% confidence is the range of 1000, that is the mean, is the range x bar plus minus the standard error estimate, which is like saying 1000 plus minus 37.5519. So it's like saying between 1037.5519 and 1000 minus 37, which will be around 963. No, 950. No. Yeah, 963. In that range, you are likely to find the true value. Okay. So that is the implication. All right. So then All right. Then you are asked, over what interval would 50% of the entire population fall? So if you want 50%, that is like asking the best estimate range with only 55% confidence. So what you need to do is re-evaluate SEE with T corresponding to 50% confidence. So if I bring back this table, that will be 0.727. Point 727. Okay, so you have to go back here, and the standard error estimate will now be 0.727 with the remaining things being the same, 35.7771 divided by 6 power half. So that is equal to 0.727. So 0.727 times standard deviation divided by square root of 6. Oops. That is 10.6185. 10.6185. So what you would write is, this will be 1000 plus minus 10.6185. So if you want to just say something with only 50% confidence, the range is narrower. If you want to say it with more confidence, the range is wider, like wider than 50%. If you want to say this with 99% confidence, it's actually 4.032. So the range will be even higher. So if you do this with 90% confidence, you'll have to multiply this by 4 instead of 2.5, and you will get an even wider range. So that's the idea. Okay. All right, so let me go up here and go over this table like I did yesterday. So these 5 problems is what you can expect to do in 2 hours. You are allowed to bring any notes or devices or pre-prepared Excel sheets, anything that you will think will help you. So for the first problem, it will be a nonlinear equation with either Newton-Raphson or bisection method. Out of many methods we saw, I'm just asking 2. The second problem will be a least squares regression problem with a quadratic function, or fitting a linear function by performing some kind of a linearization transformation to the data. I think we have done some examples related to both in the class, which you can see in your notes. The third problem will be either trapezoidal rule or Simpson's 1/3 rule only. So you don't have to study anything else for now, just these 2 methods. The fourth problem will either be a first order ODE using RK4 method or a second order ODE using Euler method. Euler method is the simple method. The last problem will either be a t-statistics problem or a normal distribution problem, both of which will involve either the t-statistics table or the normal distribution table. I'll provide the table as a handout, but you need to be able to use it. Of course, you can bring your book and handout and everything. Okay. So, any question?
I have a question about the T table.
Yeah.
You said when it's small, you don't use n-1. So when do you use?
No, you always wait. You always use n-1. That is, when you calculate standard deviation, you put n-1, and the degrees of freedom nu, it is always defined as nu is n-1. Remember that, or actually, yeah, nu is n-1. It's given in the handout. Yeah.
Okay, so always use n-1 when trying to find the T value.
Yep.
Okay.
Yep. You always use the n-1. the only place where you will use n is when you are trying to do that square root of n. That is when you calculate the standard error estimate. There is a square root of n here. So this is 6. This is 5. That's it.
Thank you.
Yeah. All right. So that is good. I'm glad the both of you are here. And what I'll do now is clean up these files and repost them shortly. And you can look at them. If you have any questions between now and Thursday or maybe tomorrow, you can email me. I will be coming to campus tomorrow, but I have meetings. But we'll try to find the time to talk to you if you want to. Okay, but email works best. Okay. All right. I'm going to
Okay, thank
stop
you.
my share. Yeah, sure. Thank you and good luck. Bye.
Thank you. Bye.